Let's talk about one of the most frustrating things in modern life. Your tech just stops working. In this explainer, we're going to pull back the curtain on all those confusing problems and give you a super clear, step-by-step guide to becoming your own tech hero.
Right? This question. We've all been there, staring at a frozen screen, that little spinning wheel of doom just mocking us. It feels like a total dead end. But what if I told you that you already have all the tools you need to figure out exactly what's gone wrong?
So, here's our game plan. We're going to follow what's basically a troubleshooting funnel. We'll start with the easiest software checks, the low-hanging fruit, and then work our way down to the physical stuff, the hardware. By the end, you'll have a logical process to solve just about any connection headache.
Okay, let's dive right in. Now, before you even think about unplugging a single cable, hold on. The very first clues are usually hiding right inside your computer. It's time to do a little digital detective work with a tool that's already built into every version of Windows.
This right here is the command prompt. Yeah, it might look a little old school, little retro, but trust me, it is incredibly powerful. And getting to it is super easy. Just pop open the run box, type CMD, and hit enter. Boom. This is our mission control for figuring out what's really happening on your network. The first command you've got to know is ipconfig. Think of it like asking your computer for its driver's license. Just typing ipconfig/all shows you everything. Its unique IP address, the gateway it uses to talk to the internet, all of it. Now, if things are acting weird, you can use release and then renew to basically ask the network for a fresh, new IP address. And flush DNS, that clears out your computer's short-term memory of website addresses, which can fix all sorts of weird connection problems. Okay, next up is ping. This is like sending a little scout out into the network to see if the road is clear. You always start by pinging 127.0.0.1. That's your own computer. It's like talking to yourself. If you get a reply, you know your own network card is working fine. Then you can try to ping a website to see if you can actually reach the outside world. And tracert is even cooler. It literally shows you every single stop your data makes on its journey across the internet.
So, if all the software checks seem okay, it's time to get out of your chair and look at the physical world. I know, it sounds almost too simple, but you would be absolutely shocked how often the problem is just a cable that's been kicked loose. Never ever underestimate the simple fix.
And this little guy is the unsung hero of that physical connection, the RJ45 connector. You know, it's that clear plastic plug at the end of every network cable. And inside, you've got 8 tiny little copper pins, and those pins are the physical superhighway that all your data travels on.
But here's a twist. Not all of those cables are created equal. A straight-through cable is what you use 99% of the time. It connects different kinds of devices, like your computer to a router. But a crossover cable is special. It's built to connect 2 of the same kind of device directly to each other, like one PC to another PC, by swapping the send and receive wires inside. It's a key difference to know about.
All right, now let's go a little deeper and look inside the cable itself. Because it's not just a random jumble of colored wires in there. There's a very specific code, a wiring standard, that makes everything work together perfectly. And here they are, the 2 main standards, T568A and T568B. As you can see, the color order is a bit different between them. Now, T568B is, by far, the most common standard you'll see today. But you know what the most important rule is? Consistency. For a normal straight-through cable, both ends have to be wired in the exact same order, to the exact same standard. Period.
So here's a cool little secret. Even though there are 8 wires inside that connector, for most standard internet connections, only 4 of them are actually doing the heavy lifting. As you can see here, pins 1 and 2 are for transmitting data out, and pins 3 and 6 are for receiving data in. So what about the other 4? Well, a lot of the time they're just unused, or they get used for cool stuff like power over Ethernet, which can send electricity through the cable to power a device like a security camera.
So really, the most crucial part is just getting that color order right. This slide gives you a quick rundown of how you'd make your own cable. You just trim the outer jacket, you untwist and straighten out the little wires, arrange them in that T568B color pattern, snip the ends so they're perfectly even, and then push them into the connector and give it a good firm crimp. It's a handy skill that can totally save you in a pinch.
But what if? What if your software settings are perfect, your cables are plugged in tight, and things still aren't working? Well, at that point, the problem might not be the network at all. The next logical step is to start listening to what your computer itself is trying to tell you.
So the moment you press the power button, your computer runs a super quick health check. It's called the Power On Self-Test, or POST. And if it finds a major problem with a critical piece of hardware, it will let you know, not with words on a screen, but with a series of beeps.
These beeps are a language, and this table is basically your translator. For example, if you hear nothing at all, no beep, it could be the power supply. A long non-stop beep often points to a problem with the memory, the RAM, and that classic one long, two short beep pattern, that's the universal signal for a video card failure. Your computer is literally telling you what's wrong.
And then there's this, the dreaded, the infamous blue screen of death. If you see this, it means Windows has hit an error so catastrophic that its only option was to just stop everything. This is almost never a network issue. It's a huge red flag for a major problem with hardware or a really important software driver.
Okay, wow, we have covered a lot of ground. So let's take a second, recap everything, and put together the essential toolkit that you've just learned how to use. Let's combine all these steps into one simple, logical process.
And here it is, your go-to checklist. You always start with the software, run ipconfig and ping. If that doesn't solve it, you move to the physical layer, check those cables and connectors. After that, you can get granular and inspect the cable wiring itself. And finally, if none of that works, you start listening to the hardware for beep codes and watching for those critical errors like the blue screen of death. And hey, one last piece of pro-level knowledge for your toolkit. The maximum recommended length for a standard Ethernet cable is 100 meters, which is about 328 feet. If you go any longer than that, you really risk getting errors and a serious drop in your network speed. So try to keep your cable runs tidy and under that limit for the most stable connection.
So there you have it. You now have the knowledge and the process. You've gone from being confused to being confident. So the next time you're staring down a stubborn tech problem, what's the very first command you're going to type? Or the first plug you're going to check? You got this.